next question. Question number 22. Compute limit extends to infinity x square plus 5x plus 2 by 2x square minus 5x plus 1. So whenever x tends to infinity is given, we proceed this way. First we write the given limit. Limit extends to infinity x square plus 5x plus 2 by 2x square minus 5x plus 1. Now we need to take the highest power of x common from the numerator and denominator. So we take x square common. So we get 1 plus 5 by x plus 2 by x square by limit extends to infinity. Again we take x square common. So we get 2 minus 5 by x plus 1 by x square. X square get cancelled. So limit extends to infinity. As x tends to infinity, 1 by x and 1 by x square tends to 0. So we get 1 plus 5 by x plus 2 by x square by limit extends to infinity. As x tends to infinity, 1 by x square tends to 0. So that is 2 minus 5 by x plus 1 by x square. So that is 1 plus 0 plus 0 by 2 minus 0 plus 0. That is 1 by 2. Now take the next question. Compute limit extends to 0 x square sine 1 by x. Now for x not equal to 0, we have a condition that sine 1 by x lies in between minus 1 and plus 1. Therefore, if I multiply x square on all the sides, we get minus x square less than or equal to x square sine 1 by x less than or equal to x square. Now since limit extends to 0, minus x square is equal to limit extends to 0 x square, and which is equal to 0. Therefore, limit extends to 0 x square sine 1 by x is equal to 0. Now take the next model. Limit extends to infinity 8 mod x plus 3x by 3 mod x minus 2x. So first we write the given limit. Given limit extends to infinity 8 mod x plus 3x by 3 mod x minus 2x. Now we have the modulus concept, that is, if x tends to infinity, which implies x is greater than 0, that is x is positive. So mod x will be equal to x. Now we take limit extends to infinity 8 mod x plus 3x by 3 mod x minus 2x is equal to limit extends to infinity. We are replacing mod x with x. So 8x plus 3x by 3x minus 2x. That is limit extends to infinity. 11x by x. X cancel. Answer is 11. Now take the next question. Limit extends to infinity 3x square plus 4x plus 5 by 2x cube plus 3x minus 7. So first what is given to us? Limit extends to infinity 3x square plus 4x plus 5 by 2x cube plus 3x minus 7. So over here, from the numerator, I will take the highest power common. So I will take x square common. We will be left over with 3 plus 4 by x plus 5 by x square. And in the denominator, we take x cube common. So we are left over with 2 plus 3 by x square minus 7 by x cube. X square get cancelled. That is limit x tends to infinity 1 by x into 3 plus 4 by x plus 5 by x square by 2 plus 3 by x square minus 7 by x cube. So limit x tends to infinity. As x tends to infinity, 1 by x tends to 0. So we have 0 into 3 plus 0 plus 0 by 2 plus 0 minus 0. Here I am substituting the limit. So over here I write 1 by x tends to 0. So that is 0 into 3 by 2, which is equal to 0. Now take the next question. Compute limit x tends to infinity root over x plus 1 minus root x. First, let us take the given limit. Limit x tends to infinity root over x plus 1 minus root x. Now rationalize the numerator. So that is limit x tends to infinity root over x plus 1 minus root x into root over x plus 1 plus root x by root over x plus 1 plus root x. Now numerator is in the form a plus b into a minus b. It can be written as a square minus b square. So x plus 1 minus x by root over x plus 1 plus root x. X minus x get cancelled. So you get now directly substitution 1 by. Now directly if we substitute, we will get infinity. So we cannot do like that. So what we will do is from the denominator we take root x common. So we are left over with root over 1 plus 1 by x plus root x. From the first part only we are taking root x common. Now from these both terms, if we take again root x common on the whole, we will get root over 1 plus 1 by x plus 1. So everywhere you get limit x tends to infinity. Here also limit x tends to infinity. So as limit x tends to infinity, 1 by x tends to 0. So this is 1 by root x into 1 by root over 1 plus 1 by x plus 1. So that is root 0 into 1 by root 1 plus 0 plus 1. 0 into 1 by 1 plus 1. That is 0 into 1 by 2, which is equal to 0. Now take the next question. Compute limit x tends to infinity root over x square plus x minus x. First I am writing the given limit. Now we rationalize the numerator. So you will get limit x tends to infinity root over x square plus x minus x into root over x square plus x by root over x square plus x. That is limit x tends to infinity. Numerator is in the form a plus b into a minus b. So that is a square minus b square. So x square plus x minus x square by root over x square plus x plus x. X square minus x square get cancelled. So that is equal to Now limit extends to infinity x by, from the denominator if I take x square common within the root, we will get 1 plus 1 by x. And if I take this x square out, it will become x. It will become x. And if I take that x common, we will get root over 1 plus 1 by x plus 1. Now this x and this x get cancelled. Now we can apply the limit 1 by root over 1 plus 0 plus 1. So as x tends to infinity, 1 by x tends to 0. So that is 1 by 1 plus 1, which is equal to 1 by 2. Take the next question. Show that limit x tends to 0 plus 2 mod x by x plus 1 is equal to 3. So first let us take LHS. LHS is limit x tends to 0 plus 2 mod x by x plus 1. Now if x tends to 0 plus, which implies it is right hand limit. So x is greater than 0, which implies mod x is equal to x. So now let us take the LHS again. Limit x tends to 0 plus 2 mod x by x plus 1. Now in the place of x, mod x, we can write x. So 2x by x plus 1. X cancel. Now apply the limit. 2 plus 0 plus 1, which is equal to 3. That is RHS. Now take the next question. Show that limit x tends to 2 minus mod x minus 2 by x minus 2 is equal to minus 1. So first let us write given. Limit x tends to 2 minus mod x minus 2 by x minus 2. So if x tends to 2 minus, which means it is left hand limit, and so x is less than 2, which means x minus 2 is less than 0, which means mod x minus 2 is minus of x minus 2. Now let us take LHS. Limit x tends to 2 minus mod x minus 2 by x minus 2 is equal to limit x tends to 2 minus mod x minus 2, we can write it as minus of x minus 2 by x minus 2, x minus 2, x minus 2 cancel. That is minus 1, that is RHS. Therefore, limit x tends to 2 minus mod x minus 2 by x minus 2 is equal to minus 1. Now take the next question. Find limit x tends to 3, x cube minus 3x square by x square minus 5x plus 6. So first let us write the given limit. Limit x tends to 3, x cube minus 3x square by x square minus 5x plus 6. That is equal to limit x tends to 3. From the numerator I will take x square common, so I will be left over with x minus 3. And the denominator we will split minus 6x plus x 1 minute. We will split in another way. Minus 3x minus 2x plus 6. So that is limit x tends to 3. X square into x minus 3 by, if I take x common, we will be left over with x minus 3 minus 2 common, x minus 3. So that is limit x tends to 3, x square into x minus 3 by x minus 3 into x minus 2. Now x minus 3 gets cancelled. Now substitute the limit. 3 square by 3 minus 2. 9 by 1, which is equal to 9. Take the next question. Compute limit x tends to 0 e power 7x minus 1 by x. So first we will write the given limit. Limit extends to 0, e power 7x minus 1 by x. Now we will be using a standard limit over here. Limit extends to 0, e power x minus 1 by x is equal to 1. But in the question, in the numerator, e power 7x is given. So in the denominator also you should have 7x. So we are multiplying and dividing by 7. So 7 I am multiplying, so I am writing it outside. Limit extends to 0, e power 7x minus 1 by 7x. So I should write here as x tends to 0, 7x also tends to 0. That is equal to 7 into 1, which is equal to 7. Very, very important. This is also same model. Take the next question. Compute limit extends to 0, e power 3x minus 1 by x. So first we will write the given limit. Limit extends to 0, e power 3x minus 1 by x. So here again we are applying the same limit. What is the standard limit? Limit extends to 0, e power x minus 1 by x is equal to 1. So over here in the numerator you have 3x. So in the denominator also you should have 3x. So I am multiplying and dividing by 3. So that is 3. Limit extends to 0. E power 3x minus 1 by 3x. So that is 3 into this whole limit value is 1. That is equal to 3. Take the next question now. Evaluate limit extends to 1 log x to the base e by x minus 1. So first let us write the given limit. Limit extends to 1 log x to the base e by x minus 1. Now put x minus 1 is equal to y. So x will become y plus 1. So as x tends to 1, which implies y tends to 0. Now coming back to the limit extends to 1 log x to the base e by x minus 1. So we are completely changing it into y. So as x tends to 1, y tends to 0. And log x can be written as 1 plus y to the base e by y. Now we have a standard limit. Log 1 plus x to the base e by x will become 1. Take the next question. Compute limit extends to 3, x square plus 3x plus 2 by x square minus 6x plus 9. So directly we can do the substitution here. So first we will take given limit extends to 3, x square plus 3x plus 2 by x square minus 6x plus 9. Direct substitution 3 square plus 3 into 3 plus 2 by 3 square minus 6 into 3 plus 9. 9 plus 9 plus 2 by 9 minus 18 plus 9. 20 by 0. Anything divided by 0 is infinity. Infinity is the answer. So take the next question. Compute limit extends to 2 plus step x plus x. Step x is the greatest integer function and limit extends to 2 minus step x plus x. So first we will find right hand limit. Right, the first one is the right hand limit. The next one is the left hand limit. So first let us find out right hand limit. That is limit extends to 2 plus step x plus x. So here step x is the next greatest integer function. So step x will be 2 here. 2 plus 2 is 1. 2 plus 2 is 4. Now left hand limit is limit extends to 2 minus. So in this case we have to take step x as x minus 1. So x is 2. So step x will be 1. 1 plus 2, that is equal to 3. Take the next question. Compute limit x tends to 0 e power 3 plus x minus e cube by x. So first let us write the given limit. Given limit x tends to 0 e power 3 plus x minus e cube by x. So that is limit x tends to 0. E power 3 plus x, we can write it as e power 3 into e power x minus e power 3 by x. So that is limit x tends to 0. If we take e power 3 common, e power x minus 1 by x. So e power 3 is a constant, so I bring it out. So limit x tends to 0, e power x minus 1 by x. This is a standard limit now, whose value is 1. So e cube into 1. The answer is e cube. Now take this question. Show that limit x tends to 0 plus mod x by x is 1 and limit x tends to 0 minus mod x by x is minus 1. So we use the definition of modulus here. So if x tends to 0 plus, which implies x is positive and which implies mod x is x. And if x tends to 0 minus, which means x is negative, and in that case mod x is equal to minus x. So first let us take limit x tends to 0 plus mod x by x. That is limit x tends to 0 x by x. In this case mod x will become x. X cancel, answer is 1. And in the next case limit x tends to 0 minus mod x by x, that is limit x tends to 0, mod x will become minus x in this case. So x cancel, that is minus 1. Hence proved. Take the next question. Compute limit x tends to 0 e power sin x minus 1 by x. So first let us write the given limit. Limit x tends to 0 e power sin x minus 1 by x. So over here I will multiply and divide by sin x. So limit x tends to 0 e power sin x minus 1 by x into sin x by sin x. Now we have a standard limit. Limit x tends to 0, e power x minus 1 by x is 1. But over here in the place of x you have sin x. So in the denominator also we need sin x. So I am just rearranging the terms. E power sin x minus 1 by sin x into limit x tends to 0. Now whatever is left we will write sin x by x. Now this is also a standard limit. This is also a standard limit. The first one, its value is also 1 and the second one's value is also 1. That is 1.